Today, we're going to start our work on a new topic. We're going to be starting into topic 11, which is a focus on circles. So today, we're just going to start with some basic notes about circles. And we're going to focus on center, radius, and diameter. So before we get started, we really need to talk about what a circle is. So a circle is a shape in which the outside or boundary lines are all equidistant from the center. And that just means that they're all the same distance. All right. Then we're also going to talk about line segments. A line segment is a line with two distinct endpoints. So if you're looking at the circle over here, there are a few different line segments that we can look at. We're looking at the line between 2 points. So we could label this AB. That's probably one of our easiest ones. And we write that as just AB with a line over top of it. We could also look at the point AC. And really, we could also look at the point BC. So those are all line segments that are on our circle. We could write these backwards. So we could write them as BA, CA, or CB. It doesn't really matter which order, as long as you name both endpoints and you write it with a line above it. Okay, so then our next vocabulary word that we're going to talk about is something called diameter. So a diameter is a line segment that passes through the center of the circle and has both endpoints on the circle. So for example, that would be point BC. All right, so let's move this down so we can see a little bit more. The next vocabulary term we're going to talk about is a radius. The radius of a circle is a line segment that has one endpoint on the center, which would be here, and the other somewhere on the circle. So we look over here at our diagram. From here, out here would be a radius. From our center, out here would be a radius. It's any line segment that goes from the center to any point on the circle. So our radius is going to be half of our diameter. And the plural form, if we have more than one radius, that is called radii. So you're going to hear that from time to time. So I want to make sure that you're understanding what that word means. So if you hear radii, you know that that's just the plural form of radius. So again, if we take a look over here at our example, again, the diameter is going to go all the way through the circle. It's going to cut through the center. So in order to be a diameter, it has to have endpoints on, both endpoints need to be on the circle, and it needs to go through the center. For it to be a radius, it needs to go from the center out to a point on the circle. All right, so we're going to do a little practice here in our work with circles. So let's take a look at this example here. The first thing that we're going to do is we are going to identify some radii and some diameter. So if we look in the box here, we have some different options. So we're going to use this circle here. It says an art class developed this logo to represent the school in an art show. Determine which segments are radii and which are diameter. So what we're going to look at are some different options here. Let's start with line segment AC. If I look at that on my circle, that's going to start here at A and go all the way across to C. So I have two endpoints on my circle and it cuts through the center, which means that's going to be a diameter. So I'm going to write that down here under diameters. All right, so then we look at AD. So that's going to take my point here and come down to that point on my circle, D. We're going to come back to this point, It does not go through the center of my circle, so it's not going to be a diameter, and it doesn't go from the center of the circle out, so it's not going to be a radius. So we'll talk about that in just a moment. Let's take a look at this other point here, PB. So that means I'm going to start in the center and go out to a point on my circle. So that means since it starts at the center and goes out to a point on my circle, that is going to be a radius. All right, let's take a look at this one here, PD. Again, I'm starting at my center. I'm going out to a point on my circle. So that is also going to be another radius. Okay, so PC, again, I'm starting at my center and going out to a point on my circle. So that will be another radius. AP, so this is going from a point on my circle, but it's going to the center, which will give me another radius. Okay. And then we have the point AB. The point AB is up here, and it's going through the circle, and it does have endpoints on the circle. So again, it's not going through the center though. So we want to come back to this. I'm going to scroll up a little just so we have some more space. Both of these points that we haven't talked about yet, I'm just going to kind of rate them over here. We have AD and AB. So again, going from this point on the circle across my circle to point B, and from A down to D. They do cut through the circle, they just don't go through the center. So they are, both of these points, we're going to say are neither radius or diameter. They are actually something called a chord, but I'm not going to make you write that out. They are neither radius nor diameter because they don't pass through the circle, the center. So because they do pass through the circle, but they don't pass through the actual center, they are not going to be a radius nor a diameter. They're, like I said, there's something called a chord. They do exist. They do cut through the circle, but they're just not a radius nor a diameter. Okay, so we are going to continue working here, and we're going to look at another example. So how many radii are shown? So we are first going to list all of our different radii. So remember, a radius has to start at the center and connect to a point on the circle. So the first one that I see here, I'm going to start at O, and I'm going to come out here to A. So that's going to be O. A is 1. Now I can also come over here to O, B. I can go from O to C, and also O to D. So my radii are OA, OB, OC, and OD. Now, we could technically draw an infinite number of radii, but since we're looking at these specific points, that means there are going to be 4 total radii in this circle. So we have the points OA, OB, OC, and OD. The rest of our segments would be something else. It'd either be chords or diameter. All right, so let's take a look. We're going to move on to the back, and we're going to do some more work with our circles. So the first thing we're going to do is we're going to solve some problems using radius and diameter. But in order to do that, we are going to kind of set up some different equations or some formulas so that that'll help us to solve. So when we are working with diameter, what you've probably noticed already is that one diameter is equal to 2 times our radius. Since our diameter goes all the way across our circle through the center, it's the same as having 2 radius. So diameter is equal to 2 times our radius. And then we can also use that same way of thinking to calculate our radius. If we want to know radius, we can just do our diameter divided by 2, or half of our diameter. So we're going to use those formulas to help us solve some of these problems. In our practice, it says the distance from a seat on the Ferris wheel to the center of the Ferris wheel is 221.5 feet. Approximately how tall is the Ferris wheel? Okay, so what we are being told here, a couple things we want to look at. We are told that from the seat, which is on the outside of the Ferris wheel, to the center. So we're thinking about from the outside to the center. A lot of times it's helpful to kind of draw a picture. So I'm just going to draw my Ferris wheel with my circle and my center. So that means from the seat, we'll say the seat's right here, to the center, that is 221.5. Okay, so that's going to be this segment here. Now, we want to know approximately how tall the Ferris wheel is. That means all the way across. So if this part here is 221.5, that is going to be my radius. And we know that in order to find a diameter, which is the length all the way across, that we multiply our radius times 2. So to find how tall it is, we want to find the diameter, and the diameter is equal to 2 times our radius. And we just said our radius is 221.5 feet. Okay, so then all I have to do is multiply. I'm going to multiply 2 times 221.5, which I can just multiply that out over here. All right, 2 times 5 is 10. I'm going to write my 0 and carry my 1. 2 times 1 plus 1. 2 times 2, and 2 times 2. Now, I did have 1 decimal place here, so I want to make sure I move that over. And my answer is 443 feet tall. So my diameter is 443 feet. All right, so then in this next problem, in the diagram, ST is 4 1/3 feet. So that means this diameter, this line segment here, is 4 1/3. What is the length of SO? So now what I'm looking for is this part here. ST is our diameter. It goes all the way through the circle and it cuts through the center. And we know that's 4 1/3. We want to know the radius. SO is a radius, so we know that our radius, we can find that by taking our diameter and dividing by 2. So I have a fraction for my diameter, and that's fine. I'm going to do 4 1/3 divided by 2. But since I've got fractions, I'm going to go ahead and write that as 2 over 1. Then I want to do keep change opposite. But remember, we want to do our check mark because I want to convert this to an improper fraction. So 4 times 3 is 12, plus 1 is 13. So I have 13/3 times, right, keep change, and then I'm going to flip. So I'm going to do 1/2. When I multiply across, I get 13/6. And when I simplify that, 6 goes into 13 2 times with 1 left over. So my answer is 2 1/6 feet. All right, so now we're going to take this a little bit further and we're going to continue solving some problems. But now we're going to solve some problems with an unknown, meaning we're going to use variables. So use what you know about diameter and radius to set up an equation. And now we want to remember that we use what we know, right? We're going to solve the equation by using opposite or inverse operations. Okay, so we're going to solve the equation by using opposite operations to isolate the variable. All that means is I want to get my variable, right? A lot of times that's my x, my variable by itself on one side of the equal sign. And to do that, we're going to use opposite operations. All right, so let's scroll down and look at these two problems. All right, so number one says the expression 3x minus 1 represents the diameter of the orange slice. What is the value of x? Okay, so first of all, this right here, this 3x minus 1 is my diameter, right? So what they give us down here, this 2.5 inches, this is our radius. Okay, so what do we know about radius and diameter? We know that our diameter is equal to 2 times our radius. So that means if I want to figure out the length of my diameter, I'm going to do 2.5 times 2. When I multiply 2.5 times 2, I get 5. Now, this is my diameter, and 3x minus 1 is my diameter. So I can set those two equal to solve for x. So 3x minus 1 equals 5. Now, I just solve how I would solve any equation. I'm going to draw my line down my equal sign, and then I'm going to use my opposite operations. I have minus 1, so to get rid of minus 1, I'm going to add 1 on both sides. That's going to leave me with 3x on the left and 6 on the right. In order to get my variable by itself, I want to divide by 3. My 3's cancel out, and 6 divided by 3 leaves me with x equals 2. So in this problem, the value of x is 2. All right, so taking a look at question 2, we are going to, let me scroll up a little so we have more space. We want to know, it says if km equals 2x minus 4. That means this whole line segment here is 2x minus 4. And LM, that means this part here, is 12. We want to know the value of x. Okay, so we have a similar problem to what we had in the last one. My radius is 12, and I know that my diameter is 2x minus 4. So I want to use my number here, my radius, and actually calculate what that diameter would be. So diameter is equal to 2 times radius. So we're going to do 2 times 12. That tells me my diameter is 24. Okay, I also know that my diameter is 2x minus 4. So in order to solve for x, I'm going to write 2x minus 4 equals 24. All right, now line down the equal sign, and I'm going to use opposite operations. And I'm just going to bring that down here so we have a little more space to write, since my video box is in the way. All right, so I'm going to add 4 on both sides, which will leave me with 2x on the left and 28 on the right. Then to get x by itself, I just need to divide by 2. 28 divided by 2 is 14, so x equals 14. All right, I hope that this makes sense. If you have any questions, please ask me for help. Or you can go back, rewatch this, go back to any parts that you were unclear about. From this point, we're going to work on just identifying some parts of the circle and just working with radius and diameter a little bit more. Hope this was helpful, and let me know if you have any questions.